An innovative idea is raw, explosive energy. It's chaotic, but left entirely to its own devices, that energy simply dissipates into the void. To actually capture it, you need a rigid structure to force it into reality. In operations management, innovation is strictly defined as the generation of novel value. That could mean small, incremental improvements to an existing service, or inventing a completely new product from the ground up. Design is the operational mechanism that takes that raw novelty and configures it. It determines the looks, arrangements, and workings of an idea, forcing it to conform to physical constraints, financial realities, and market demands. Without the discipline of design, an innovative concept remains a theoretical abstraction. It might look impressive on a whiteboard, but it cannot scale, and it cannot be reliably produced. Conversely, if you have a robust design process but zero innovation, your operations will simply become highly efficient at refining obsolete products that nobody wants anymore. To prevent both of these failures, we need to construct a step-by-step operational pipeline. We will classify the specific type of knowledge being generated, screen those concepts through a strict set of criteria, and deploy the right organizational architectures to execute them. Generating ideas is cheap. Disciplined execution through a rigorous design process is what actually separates a surviving organization from a failing one. Progress in any industry is never a straight line. Every new idea eventually hits a ceiling where it reaches its natural limits of performance. This graph plots the life cycle of an innovation. We start with a slow introduction phase where gains are sluggish. Then performance shoots upward in rapid growth. Eventually, it hits maturity, and improvements become difficult, completing this S-shaped curve. To maintain growth, organizations stack multiple S-curves. Operations managers cannot afford to ride a single success. They must plan for the obsolescence of their current product and begin designing its replacement now. Before designing a pipeline for that replacement, you must classify the type of innovation you are dealing with to accurately assess its risk profile. The Henderson-Clark model categorizes innovation by component versus architectural changes. Low impact on both is incremental innovation. Changing a component only is modular innovation. Reconfiguring existing components is architectural innovation. Completely new components in a new architecture is radical innovation. Misclassifying an innovation misaligns resources and expertise from the start, often compromising the design phase before the first sketches are even drawn. An organization will generate hundreds of raw concepts. These must be ruthlessly filtered down until only a single, viable product is left ready for production. This reduction is managed through the design funnel. The first filter is feasibility. Can we actually do this? Surviving concepts face acceptability. Is this worthwhile financially? Finally, ideas hit vulnerability. What happens if this goes wrong? Leaving only a single viable concept. The design funnel serves as an operational defense mechanism, systematically identifying and removing weak ideas early in the cycle. Surviving the design funnel is only the first hurdle. Operations teams now face a massive translation problem, converting subjective marketing promises into objective engineering realities. Operations uses quality function deployment to link customer desires to design metrics. Subjective customer whats form the left column, objective hows form the top row. The central grid spores the intersections, showing exactly how the product delivers on customer demands. Quality function deployment prevents misalignment. It bridges the fatal gap between what a customer expects to buy and what the organization actually builds. Even a perfectly translated design is useless if it arrives too late. Delays in time to market destroy potential revenue, while simultaneously ballooning development costs. Comparing execution. The top shows a sequential timeline, handed off department by department. The bottom is simultaneous design, actively overlapping tasks. To achieve this speed, organizations must abandon functional silos and transition to a matrix structure, integrating cross-functional teams. Operational speed is a structural choice. Choosing simultaneous design means sacrificing initial organizational comfort to ensure accelerated market dominance. These operational models encounter significant complexity in high-constraint environments. In Southern Africa, resource limitations force a reliance on frugal innovation to achieve viable results. Following the end of apartheid, South Africa launched the Reconstruction and Development Program, an ambitious socio-economic policy aimed at eradicating mass housing shortages. To deliver housing on this scale, the design process had to be rigidly defined. The concept aimed to provide dignity and basic shelter. The package was the standardized physical house itself, and the process governed the contractor selection and community handover. But we can assess this initiative through the design funnel. Looking at feasibility, the project strained against extreme logistical challenges, limited technical resources, and a severe shortage of skilled contractors needed on the ground to execute the build. Applying acceptability and vulnerability reveals deeper flaws. Highly standardized packages often struggle to satisfy incredibly diverse community needs, and the vulnerability risks of missing supporting infrastructure, like water, sanitation, and reliable roads, were frequently ignored. The struggle of the program to fully deliver on its initial housing projections can be traced directly back to ignoring these exact operational screening criteria. Large-scale failure is rarely a failure of intent. It is almost always a failure to rigorously enforce the design process against unforgiving physical reality.